This is a real picture of our planet rotating in space. Neither artist's impression nor computer graphic, but time-lapse from a space probe. It's this spin of the Earth, never before recorded from space, that causes the sun to trek daily across the sky. A 24-hour cycle that makes day and night, sunrise and sunset. What many don't realize is that this same spin moves the stars through the sky. A combination of the rotation of Earth and its annual orbit of the sun means that our perspective of the cosmos through the sun changes by 4 minutes every day. This line is a partial view of the sun's seasonal movement against the background stars, the ecliptic. Astrologers of old placed figures along the line, forms suggested by groups of stars, groups we know today as constellations. The constellations of the ecliptic formed the zodiac, a pattern found even in the temples of ancient Egypt. Astrology and astronomy have long diverged, but the mythical names of the constellations persist. To find their way about the heavens, modern astronomers divide the sky into a grid. Longitudinal lines are called right ascension, calibrations of hours, minutes and seconds. Latitude or declination marks degrees north or south of the celestial equator. The index finger and little finger are the simplest measuring device. At arm's length from the eye, they measure off roughly 15 degrees against the sky. That's equivalent to 30 moon breadths. For the moon, not to scale here, fills about half a degree. The clenched fist equals some 10 degrees. 3 fingers, 5 degrees. 1 finger, approximately 1 degree, or 2 moon breadths. This deliberately defocused photograph reveals the true colors of stars. We see them like this because our eyes are insensitive to the subtleties of starlight. The stars should look like this, an astronomical photograph, or the view through binoculars. Good binoculars are the first essential for a new observer. Marked on every pair are numbers specifying magnification and lens size. These 10 times 50. The 10 indicates that this pair will give a 10-fold magnification of the image. The 50 is the size of the lenses, both 50 millimeters. Here the eyepieces are marked 5 millimeters. That's the width of the exit pupil, the light beam from the eyepieces. The size you need depends on age. If you're under 40, the pupils of your eyes will dilate to 7 millimeters. If you're over 40, just 5. So, if you're young, you'll see the best images through an exit pupil of 7 millimeters. Therefore, look for binoculars marked 7 times 50, or 10 times 70. By dividing the figures, you get the exit pupil. What we see in binoculars depends on where we are on Earth. The axis of Earth has the North Pole pointing close to the pole star Polaris. Thus Polaris is the only virtually fixed star in the sky. From wherever you stand on Earth, only half the sky is visible. That's why Polaris appears lower and lower in the sky, the further south you go. By the time you reach the equator, Polaris will be sitting on the horizon from, say, Nairobi. In the southern hemisphere, Polaris disappears altogether. But starting from Singapore, the south pole of the sky gets higher and higher the further south you travel. Here, with the Anglo-Australian telescope in silhouette, the stars of the southern polar region, as Earth rotates. This is a chart of the region. The Milky Way stretches across the sky, an edge-on view of our galaxy. Top center is Crux, the stars of the Southern Cross, a signpost. Extend a line through two of them, and there's the southern pole, an empty space. Within the circle are the circumpolar stars, visible any clear night. Among them, the large Magellanic Cloud and its companion, the small Magellanic Cloud, satellite galaxies of the Milky Way. Top left to Alpha Centauri. This is the brightest member of the constellation, the group of stars known as Centaurus. To the right, and Canopus, the second brightest star in the sky. It belongs to the constellation of Carina. Downwards now to Hydrus, the constellation of the Little Snake, and below to Achernar, the most brilliant star in the long and winding constellation of the river Eridanus. To the left, Parvo, the Peacock. Just above, Ara, the Altar. A little to the right, Triangulum Australe, the southern triangle, and nearest the southern pole, Octans. And there they are, the trails of the polar stars in an overnight exposure. To the northern pole now, in the second leg of this introduction to the heavens. The Milky Way is strung across the northern sky. The pole star Polaris is at the very center, shining bright in the constellation of the Little Bear, Ursa Minor. Next door, Draco, the constellation of the Dragon. Just below, Ursa Major, the Great Bear. Top center, Cassiopeia, the Queen. To the left, Hercules, another Greek hero. Next to his queen, Cepheus. And top right, the constellation of Perseus. Some bright stars, Vega in the constellation of Lyra. Higher up, Deneb in Cygnus the Swan. And to the right, Capella in Auriga. And now those northern stars in another long exposure. The best guide to the northern polar sky is the constellation of Ursa Major. From these two stars is the direction of the pole star Polaris. Polaris in Ursa Minor. A line through Polaris from Mizar in Ursa Major leads to Cassiopeia. These two in Ursa Major point to the star Capella, a brilliant point in the constellation of Auriga. This pair in Ursa Major point to another important star, Regulus. Regulus in the constellation of Leo. Finally, extend the tail of Ursa Major, and it leads to Arcturus, a red giant star in the constellation of Boötes the herdsman. Go on a little, and there's brilliant Spica. An introduction to the workings of the sky. The glory of the Milky Way, our edge-on perspective of the galaxy in which we live. An astronomical vista best observed when it's summer in the northern hemisphere and winter in the south. A time when the most powerful telescopes on Earth can peer into clouds of gas and dust. When they can glimpse the galactic center and, who knows, a black hole. Time for the stars of Alpha Centauri, little more than 4 light-years away. The season of the Milky Way. They look fixed to us, but most stars are in motion around the galactic center, although in a human lifetime they won't appear to move at all. The 200 billion stars of the Milky Way, all gently turning. One of them, our Sun, takes 200 million years to orbit the galactic center. If we could fast forward 10,000 years, the stars would reposition like this. As it is, it's the point in Earth's orbit of the Sun which determines our view of the sky. Right now, it's summer in the northern hemisphere, and towards the pole, the Sun may barely set. But in the mid-latitudes, this is the sky, the Milky Way stretching overhead. We're in the north, looking north. These are the constellations of summer. Towards the horizon, the bright yellow star, Capella. Above, in the Milky Way, within the W-shaped constellation of Cassiopeia, the debris of a star that exploded 300 years ago, Cassiopeia A massive radio source, but no good optically. The circle in the inset is our Sun. Imagine traveling away towards our nearest stellar neighbor. This is the position our star would assume in the cosmos, an insignificant dot before the W of Cassiopeia. Top right in the Milky Way in Cepheus, the pulsing star Delta Cephei. It's a so-called Cepheid variable. Such pulsing has enabled astronomers to calculate the distance of Cepheids, and therefore to measure the universe. We're now looking south, the Milky Way again, and on the far right, Corona Borealis, the northern crown. Next door, mighty Hercules. And top center, Lyra, the constellation of the Harp. In the Milky Way, Cygnus, the swan. Below, to tiny Delphinus, the dolphin. Again in the Milky Way, Sagitta, the arrow. And beneath, Aquila, the eagle. Bottom left to Capricornus, the sea goat. And at the other side of the Milky Way, Ophiuchus, the snake holder. To the right, Serpens, the snake itself. And lastly, at the bottom, Sagittarius the archer, with a hint to the right of Scorpius. The first close-up is top right in Hercules. Here is M13, a globular cluster of 100,000 stars, good through binoculars. In Lyra top center, the star Vega. Brilliant Vega has a ring of dust, possibly a planetary system in the making. Lower in Lyra is the double star Sheliak. They can't be separated in a small telescope, but they seem to stream off a trail and be so close they exchange material. Next to them in Lyra, M57, the famous ring nebula, a puff left over from a star that exploded hundreds of thousands of years ago. Excellent in a small telescope. and the debris of another ancient explosion, the Cygnus Loop, not so easy to spot. But through the Hubble Space Telescope, a shock wave still racing through space. Here's its position in Cygnus. Lower in the Milky Way to Sagitta, and a cosmic showpiece, M27, the Dumbbell Nebula. It's the shroud of a slowly dying star, and good in binoculars. Still lower to Aquila and the bright star Altair, just 16 light-years away. Altair spins so fast it has bulged into an ellipsoid. Still in the northern hemisphere, these are the summer constellations from further south, from the Mediterranean or Florida. Sagittarius is now well clear of the horizon, and beneath is Corona Australis, the southern crown. On the right, the whole of Scorpius. Up here, M16, a cluster of stars immersed in the Eagle Nebula. Fine in binoculars, they formed 2 million years ago from the gas and dust which still surround them. This central region of the Milky Way abounds in splendor. We're scanning the vicinity of Antares in Scorpius, a vast nebula, a cloud of dust and gas 5 light-years across. Thousands upon thousands of stars. The galactic center, in this case a picture from Australia. The true center, however, is obscured by cosmic fog, but there is a view by radio telescope. This radio image suggests a cloud pattern caused by a black hole, a place where whole stars are devoured. But this infrared picture upsets the theory. It shows gigantic stars unperturbed at the galactic center. The region remains a mystery. As Earth's seasonal tilt has given us summer in the northern hemisphere, so it's winter in the south. With the Milky Way arching overhead, this is the southern sky. The winter constellations from the southern hemisphere looking north. In fact, the inverse of the sky from the north. Shining brightest in the south, Alpha Centauri, a triple system, of which this red dwarf is the closest star to Earth. Proxima, just 4.3 light-years away. Here's the position of Alpha Centauri in the Milky Way. And these are the surrounding constellations. Alpha Centauri is in Centaurus. We're now looking south in the southern hemisphere. Top right in Centaurus, a globular cluster. This one is the finest example in the heavens, Omega Centauri, 1 million stars bunched together in a spherical cloud. Several of these clusters sit like satellites over the center of the Milky Way. Again in Centaurus, one of the loudest radio sources and visible in binoculars, the phenomenon of Centaurus A, neither star nor cluster nor a single galaxy. In fact, 2 galaxies in one, a galactic collision. In its annual orbit of the Sun, Earth is approaching an equinox. It's late September, autumn in the northern hemisphere, spring in the southern hemisphere. For a few days, everywhere on Earth has an equal amount of day and night, the equinox. It's a good time to study galaxies, for Earth is looking outwards, away from the distractions of our own galactic center. Exotic stars and wondrous clouds adorn the celestial stage. In the southern skies can be seen the small Magellanic Cloud, a satellite galaxy to the Milky Way. We know about the nature of stars and galaxies because they each radiate a different spectrum of light, a fingerprint. In the region of Orion, here's the light of 4 major stars analyzed by spectroscope, the fingerprints or spectra of Rigel, Sirius, Procyon and Pollux. With Sirius, for example, its spectrum can be matched against a laboratory scale. Where lines coincide, certain elements exist. We can tell what Sirius is made of. We can also discover its direction of rotation. Light shifts towards red if a body is retreating, towards blue if it's advancing. It's known as the Doppler effect. In the case of galaxies, stars moving towards us have a blue shift, and away from us, a red shift. Clues from the cosmic code. The autumn sky in the northern hemisphere. The constellations as we look north. Low in the sky, Ursa Major, in some places out of sight. Gemini, the twins. Auriga, the charioteer. Perseus. Cassiopeia, the queen. Cepheus, the king. Hercules, left over from summer. Draco, the dragon. And Ursa Minor. At the center of things in the north, Polaris. Directly lower in the sky, 7 bright stars that form part of Ursa Major. They're variously known as the Big Dipper, the Plough, and the Emperor's Chariot. One of the 7, Mizar, has a companion, so close it was used as an eyesight test in armies of old. Through a powerful telescope, Mizar is not 2 stars, but 3. The larger companion is Alcor, too far from Mizar to make the pair a genuine binary. The smaller one qualifies. We see the sky in 2 dimensions. Were we able to travel around the 7 brightest stars of Ursa Major, we'd see them in 3D. In other words, we'd realize that their distances from each other, as well as from us, are quite different. Far from the picture they present to Earth. Now, if we travel forward in time, about 100,000 years, the 7 stars will realign to look something like this. If we reverse the process by traveling back in time, they'd form another configuration. The patterns we see today are a single frame in a movie. The cosmos is ever changing. This is how the 7 stars would have appeared 100,000 years ago. More like a spear than a plough. Again, the autumn sky of the northern hemisphere. The view is to the south, and these are the constellations. Delphinus, still around from summer. The great square of Pegasus, the flying horse. Straggly Andromeda, the chained maiden. The 3 sides of the triangulum. Just beneath, Aries, the ram. and the two fishes of Pisces. Lower down, the sea monster Cetus, sometimes called the whale. To the west, Aquarius, the water bearer. And finally, the sea goat, Capricornus. Top center, the most distant object visible to the naked eye. It's the great galaxy of Andromeda. Lying in the direction of the constellation of Andromeda, the galaxy is like our own, a spiral of over 300,000 million stars, plus a couple of satellite galaxies. This one was probed by the Hubble Space Telescope in the early 90s, satellite galaxy M32. From the clarity of Earth orbit, Hubble peered into its heart. Each dot is a star shining like a sun, light which takes well over 2 million years to reach us. Low in the sky, through binoculars, a faint blur. Through a big telescope, the magnificence of the Helix Nebula. A cloud of dust and gas expanding at perhaps 40 kilometers a second. A dying puff of energy from this central star, whose corpse will be a white dwarf. High up, between the Triangulum and Andromeda, the faint galaxy M33. Visible in binoculars, M33 is one of the best face-on spirals in the sky. We're still looking south, but from the more southerly latitudes of the northern hemisphere. Low in the sky, the constellation of Piscis Australis, the southern fish. Here is the star Formelo, with an exciting possibility. There's recent evidence that it's surrounded by a cloud of cool gas. Such a cloud gave rise to the planets of our solar system. It's still late September, but we're now in the southern hemisphere looking north, and it's spring. To northerners, the constellations look upside down, but to southerners, they are the right way up. Top center, in Aquarius, a double act. A red giant and a white dwarf. The hapless giant heaving and blowing. The dense dwarf tugging matter from its distorted companion. And periodically, a gigantic nuclear detonation. R Aquarii, a very variable star. The southern sky, looking north. And now, looking south, towards the polar region, the Southern Cross and the Milky Way are low on the horizon. These are the constellations of spring. On either side of Hydrus, the little snake, like pieces broken from the Milky Way, are its two satellite galaxies. They're called the Magellanic Clouds, both visible by naked eye. The small Magellanic Cloud is only a tenth the size of the Milky Way, but it's more than 10 times closer than Andromeda, our nearest big galaxy. The large Magellanic Cloud is maybe twice as big as the small. Both are 180,000 light-years away. One day, we may all collide. Bottom right in Ara, through a powerful telescope, a beautiful nebula. A majestic cloud of red hydrogen and black dust, our last picture of spring in the southern hemisphere. The double star Capella, perpetually in a celestial waltz. A binary whose combined brilliance is a jewel in the winter sky of the northern hemisphere. A sky graced with the beauty of Orion, a constellation bedecked with magnificent nebulae and brilliant stars. And close by, a pulsar, the spinning debris of a stellar giant. Earth's solar orbit is at the stage of seasonal extremes. The northern hemisphere has the short days and long nights of winter, ideal for stargazing. In the south, it's summer. With the Milky Way well in view, these are the winter constellations. We're in the north, looking north. Below Cepheus, the star Deneb peeps over the horizon. The arrow top left near Perseus marks the home of the double cluster. This is the picture in binoculars. Two groups of stars, some 300 in each, as bright as diamonds. Bottom right, beneath Ursa Major and best seen through a small telescope, Galaxy M51, a satellite on its arm. Known as the Whirlpool, M51 has been probed by the Hubble Space Telescope, a strange cross formation at its center, evidence perhaps of a black hole. Higher up in Ursa Major and good through binoculars, a pair of galaxies, M81 at the bottom and M82, both 8 million light years away. A view to the north in winter. And this is the vista to the south. One constellation dominates the sky, the handsome figure of the hunter, Orion. But Orion is just an effect. If we could fly a great circle through space, the stars of Orion would appear quite different in their relative positions. As with all constellations, only from our perspective on Earth do the stars assume their familiar patterns. The three stars in the belt of Orion are a signpost. Join them up and they point the way to the brightest star in the sky, Sirius. Bright because it's close by in space. Sirius is part of the great dog, Canis Major. The two stars at the top of Orion are another indicator. They point to a much smaller constellation, aptly named the little dog, Canis Minor. Its brightest star is another neighbor of ours, Procyon. Take two more stars in Orion, extend a line through them, and it leads to a great multiple star, the system of Castor. Castor forms the head of one of the mythical twins in the constellation of Gemini. Back to Orion's belt, but instead of projecting towards Sirius, go the other way towards a vivid orange star. It's our near neighbor, Aldebaran, 40 times the diameter of the Sun. Aldebaran is the great eye in Taurus the Bull. In the shoulder of the bull, a star group called the Pleiades, easy in binoculars. Orion, our guide to the winter sky of the northern hemisphere. And here's a wider perspective, looking south. Orion still dominates the picture. The main constellations, with the Milky Way running from Auriga at the top to Canis Major at the bottom. Top right, in Taurus, we take a closer look at the Pleiades, the Seven Sisters. There are far more than 7. Blue, hot and young, some 250 stars bathe in the dust from which they were born. At the center, still in Taurus, a tiny pulsar. Spinning 30 times a second, the corpse of a giant star which exploded 900 years ago, a supernova that formed the Crab Nebula. Top center, in Auriga, the double star Capella. Together, they shine 160 times brighter than the sun. Top left in Gemini, the multiple star Castor, a small red binary orbiting a pair of blue binaries. 6 stars in one, and distinguishable as 3 entities through a telescope. Center left, towards Monoceros, a patch of diffuse nebulosity. A black cone of dust seems to point to a central group of stars, the Christmas tree cluster, good through binoculars. Again in Monoceros, a quite beautiful nebula, the Rosette, a clutch of baby stars in a nest of hot gas. The brightest can be seen in binoculars. If we could fly towards Orion, at 500 light-years we'd meet Betelgeuse, a red giant that could swallow the inner solar system as far as Mars. A stud on the belt of Orion, a region invisible to the naked eye, but through a telescope, a billowing cloud of black dust silhouetted against red hydrogen, the Horsehead Nebula. From Orion's belt hangs a sword. At the tip is one of the finest objects in the sky, M42, the great nebula in Orion, a place where stars are born and visible in binoculars. Again, if we flew towards Orion, at 900 light-years, we'd encounter Rigel. Rigel is a superstar, 50,000 times brighter than the sun, but it burns so fiercely it'll have a much shorter life. Bottom left to Sirius, the brightest star with a companion, a white dwarf just a few times bigger than Earth. This is a real picture through a large telescope. And this is the same part of the sky from the southern hemisphere. Join 2 points in Orion and project a line upwards. Here is the second brightest star, Canopus. Join 2 more stars in the handy signpost of Orion, and they point to the mouth of a waterway, the star Achernar. Achernar lies at one end of the long meandering constellation of the river Eridanus. The wider view in the southern hemisphere, it's summer looking north. Orion straddles the cosmic equator. Now the sky looking south, the Milky Way and the southern constellations of summer. At the top, hidden in the constellation of Puppis, a spectacular sight. Like a jellyfish, a vast globule of gas is in retreat. It's driven by energy jetting from hot younger stars. A last vista of summer. Late March, our planet is approaching an equinox. At this point in Earth's annual circuit of the sun, it's spring in the northern hemisphere and autumn in the south. From this seasonal perspective, we're looking out from our own galaxy to those that lie beyond. The world over, our heavenly vista is of the same duration. For at the equinox, day and night are equal. We look towards the constellation of Virgo and a galactic jet. And in another direction, the enigma of Eta Carina, a prospective supernova. Objects in the sky are identified by number. This is M100, Messier 100, or in the new general catalogue, NGC 4321. In the late 18th century, it was the French astronomer Charles Messier, a comet hunter, who first catalogued by number. Messier 1 was the Crab Nebula. Messier 31, M31, the great galaxy of Andromeda. M42, the Orion Nebula. 110 fuzzy objects have a Messier number. Armed with our catalogue, we explore the spring sky. We're in the north, looking north. The constellations from the mid-latitudes. Top right in Draco, the star Thuban. Thuban was the pole star of the ancient Egyptians. Today, Polaris is the pole star. In the future, this will be the pole star, brilliant Vega. Over millennia, the pole of the sky shifts roughly within this circle. From Polaris today, the axis of the Earth will tilt to point at Vega. It's caused by a 26,000-year wobble in the spin of the globe. Towards the horizon, in the constellation of Perseus, the demon star Algol. Algol appears to wink every couple of days. That's because it's an eclipsing binary, dull when one star is in front of the other, bright when they separate. Still in Perseus, it was here in 1901 that a star exploded, a nova. This was the culprit, a binary, the smaller partner feeding on material from the larger. The result, chronic indigestion and a nuclear convulsion. After another build-up, there'll be another nova. Unlike a supernova, which is once and for all. The northern sky looking south. Leo the lion. Boötes the herdsman. Corona Borealis, the northern crown. Libra the scales. Corvus the crow. Hydra the water snake. And Virgo the virgin. In Leo, the cross beneath the lion's head is a radiant from which meteors appear, but only in November. It's then that the orbit of Earth passes through a trail of debris left by a comet. The result is a shower of meteors. In Leo's case, they're called the Leonids, but it'll be 1999 before the next really big display. The whole region of Leo and Virgo abounds with galaxies, thousands of them, misty blurs in small telescopes. This one, M87, is a gigantic sphere, probably an amalgamation of several ancient galaxies. Through the Hubble Space Telescope, a great jet emanates from the galactic center. In animation now, it's surmised that the jet is being shot from a huge black hole. At the same time, material is spinning into this ultimate gravitational trap. M87 lies between Leo and Virgo and is good in binoculars. So too, further down, is another bright galaxy. M104, the Sombrero. Here, through a big telescope, a band of dust girdles the equatorial plane. From Virgo, still lower in the sky, to Corvus. This is the home of the ring-tail galaxy. In fact, two galaxies in collision. Their gravitational interaction has strewn great chains of stars across the cosmos. The sights of spring in the north. Now, from the southern hemisphere looking north, the constellations of autumn. They're largely the inverse patterns of the north. Bottom right, in Boötes, the great star Arcturus. A giant, 25 times the diameter of the Sun, the fourth brightest star in the sky, and 37 light years from Earth. With the Milky Way straddling the sky, we're now looking south in autumn. The constellations from the southern hemisphere. Top center, in the constellation of Carina, the great nebula of Eta Carina. It's just visible to the naked eye in a dazzling part of the Milky Way. At the very heart of the nebula, the most brilliant star is Eta Carina itself. Last century, Eta Carina was one of the brightest stars. Today, it seems to be hidden behind a shell of dust. Astronomers think this is a precursor to a supernova, the explosive death of a stellar giant. Down to the painter's easel and Beta Pictoris. An interesting star with a disk of dust, here in red and yellow. The star is bright enough for binoculars. Towards the center now, and to the biggest of our two satellite galaxies, the Large Magellanic Cloud. Shaped like a bar, it's a mini-galaxy with just 1/10 the star population of the Milky Way. In the left-hand side of the cloud is the Tarantula Nebula, bright enough for the unaided eye. To the right of the nebula, a star blew up and died in 1987, the closest supernova in 300 years. Before it went bang, it puffed out a ring, a picture from Hubble. And this remarkable shot following the explosion. Concentric rings of light racing through space from the seat of the cataclysm. Upwards now to Crux, the Southern Cross. Here is the Jewel Box, a cluster of brilliant young supergiants. Finally, down a little from the Jewel Box. This is the Coal Sack, not a hole in space, but the best-known dark nebula, and visible by naked eye. A brief tour of the heavens, a guide which has only hinted at the enjoyment to be had through telescope, binoculars, and by just looking at the sky.